Okay, we'll work through homework problem 526. This is the one with the outrigger on the crane, as well as we have, we'll use Excel to plot the values of theta until we achieve tipping. So when we're looking at this, what do we have going on? We have a couple of masses. So G1 is going to be pulling down there, G2 is here kind of in the middle of the boom pulling down, and then last we have our load here that's pulling straight down over as well. Those are countered by reaction forces at A and B. There's actually another set of these outriggers on the back side of this crane truck as well. So we have a number of things here. We're told that the mass of the crane and truck is 18 megagrams, and the center of mass is at G1, so that's the load that's here. That's 18 megagrams. And then at the boom has a mass of 1.8 megagrams. So G2 equals 1.8 megagrams. And then finally our load is 1.2 megagrams. This is 1.2 megagrams. And that M looks a little bit like a mu. Excuse me about that. Let me see if I can fix that. There we go. Alright, so what is the approach here? Well, first thing, we'll write some equilibrium equations. So the sum of the forces in X have to be 0. Is there anything in X? No, so that's that doesn't help us. We also have some of the forces in Y have to be 0. Does that help us out? Certainly. So we have that goes to, we have the reaction at A, I'm just going to say normal at A plus normal at B. Those are going up, right? So we have these reaction forces. The ground is pushing up at those points on the outriggers, which is supporting the crane. So that equals, so then we're also going to subtract off the 18 megagrams times our 9.81 meters per second squared to get a force, minus 1.8 megagrams times 9.81, and then 1.2 megagrams times 9.81. So that's what we have. So we can rearrange that, but then the last part, when we don't have any tipping, some of the moments around B is going to be 0. So what is creating moments around B? We have the normal force at A, and how far away from B is that? Well, we've got 2 meters plus 1 meter plus 1 meter, so 4 meters. We're going to have that times 4 meters. And that's actually a negative, right? That's creating a clockwise rotation, so that's a negative moment. And then we're going to have our load at G1. I'm just going to call it G1. It's actually going to be that 18 megagrams times gravity. G1 times 1 meter. So that's acting here. We're looking just at this moment arm. So that one's pretty straightforward. And then these next ones will depend on our angle theta. So we have this angle theta. We're not sure at what point that's going to be tipping. At some angle of theta, let's say if theta is 0, all the mass is going to be centered on the middle of this boom here. So we certainly won't have any tipping. We will have a positive moment in that case. But then as things start coming out this direction, we'll start getting some, once these centers of gravity cross the point at which B is acting, then they're going to have negative moments. So how are we going to account for that? Well, I'll write them as positive moments, and then we'll see how that works out. So we're going to have plus that force. I'm just going to call it G2 and G1, G3, excuse me, G2. So it times its moment. So it's going to be how far from this point to B. We have 1 meter plus 1 meter. So we're going to have 2 meters minus, what's our x displacement here? We're going to have 6 meters times the sine of theta. So when theta is 0, sine of theta is 0, so this part goes away and we have a positive moment. When theta is 90 and this boom is straight out over this way, we're going to have, this could be 1, so we're going to have negative 6 meters plus 2 meters, so 4 meters times that negative, so it's going to be a negative moment. So that's how we'll accomplish keeping track of whether we have a positive or negative moment. Then we'll add, and I'm going to call this G3, so the load up here I'm calling G3. It's kind of a poorly written G. G3 plus G3 times, still have that plus 2 meters, so that's where that center of rotation is happening, where our theta is changing. And now, instead of just 6 meters, we have 6 meters plus 6.25 meters minus 12.25 sine theta. Alright, so that's our moment. Oop, excuse me. Get rid of those. And let's see if I can scroll here. Okay, so we'll continue working through this. So we'll have, if we take our forces here first, so the sum of our forces around y is 0, so we find NA plus NB equals, I'm just going to call them G1 plus G2, G2 plus G3, and we can solve that later. So we'll leave that for now. Expanding this moment equation, we're going to have 4NA, so I'm taking this negative 4NA to the left side, equals G1 plus 2G2 minus 6 sine theta G2. So I expanded this out, so there's my 2G2 that came down to here, and then I have my G2 times my 6 meter sine theta here, which came there, and that's the negative sign came through there. And then we'll have plus 2G3 minus 12.25 sine theta G3. So that's the expansion of this term over here coming down into these two terms. Alright. So if we keep working through that, we'll find our normal reaction at A is going to be G1 plus 2G2 plus 2G3 minus, I'll pull the sine theta out here, 6G2 plus 12.25 G3. So I combined this term and this term and took the sine theta out front here, and so this is plus, so I have the negative sine theta, so this is a plus 6G2 plus 12.25 G3, and that's all going to be over 4. And so as sine theta changes, I can calculate what that normal reaction at A is. And when we have tipping, we have tipping when NA equals 0 or negative, right? So when NA equals 0, that's when things are perfectly balanced on those B outriggers, and you could walk up to that crane with your hand and pull up on the back and it would tip over, or you could push up on the front and it would put more reaction onto NA. So that's the criteria there. So I'm going to take this equation now and fill that in our Excel model, and then I will also go in here to our Excel and use this equation here to find what our reaction at B is. So I'll use the moments to find A, I'll use our equilibrium around forces in Y to find B, and then I'll report those in Excel. So what do we have here again? We had this giant thing. I've got that written down separately. Let me just scribble it down one more time so I don't mistakenly type it. Plus 2g2 plus 2g3 minus sine theta 6g2 plus 12.25g3, and all those g1s and g2s we have to multiply by gravity to actually find a force in newtons. So I'll just put a small g out front of that. So let me write what I just said there. So I'm going to put a little g here, where this is 9.81 meters per second squared. So that gets us an actual force in newtons. And then the other part was NB equals little g times g1 plus g2 plus g3 divided by NA, or subtract NA, excuse me. Alright, so we're going to switch over to Excel now. Alright, so here's my Excel sheet. I'm going to put my angle in degrees here. So 0, 5, 10. I'm going to go by 5s at first. I could solve that equation directly and find what the angle was where NA equals 0. Excel likes things in radians, so I'm just going to convert this into radians. Equals 2 times pi divided by 360. Excuse me, that's not right. Yes, that's right. 2 times pi divided by 360 equals this times 2 pi. So there we go. We've got 0. Let's make sure that seems to make sense. I'll keep adding this out. So we can use that fill feature. I'm going to go down to 90 degrees. We'll certainly tip by then, otherwise our boom is coming back around on us. So we'll expand out our radians. So 90 should get us pi over 2. So 1.57, that seems right. So our total reaction at A, that's our NA again. So I'm going to say equals 9.81. So that's my G times G1. And G1 in our equation was, in our problem, that was 18 megagrams. So that's 18 million kilograms, right? So 18,000 kilograms, excuse me. Plus, we have 2 times G2. And I'm gonna put another bracket here. 2 times G2, and G2 was 1,800 kilograms, right? So 1.8 megagrams, 1.8 kilograms, and then G3 plus 2 times G3, and that was 1,200 megagrams, or 1.2 megagrams, so 1,200 kilograms. And did I close it out? Okay, so I don't really need this extra parenthesis here. So that's my top, that's my G. And then I'm going to subtract out minus sine of theta. So I need a parenthesis. There's my theta in radians. I'm multiplying that by 6 times G2. And G2 again was 1,800 kilograms. And then adding 12.25 times 1,200 kilograms for my load. So that's the end of our, excuse me. That's the end of my numerator, and I realize you can't quite see what I'm typing here. Oh, you can see it down there. Okay, that's fine. And then, so that's the top of that's our numerator, and we're going to divide that by 4. So where did I make my mistake here? Oh, I have an extra. So I have mistyped something here. Sine B2. Do I have an extra? Sine B2 times that quantity. Minus sine B2 times that. All over 4. Why do I have an extra? Let me see if I put an extra parenthesis in over here, if that clears things up. Okay, now I'll need an extra parenthesis there. Does that close things out? No. Try to type performance equals 9.81. Okay, 9.81 times 18,000 plus 2 times 1800. Let me just make sure I can see if I can get rid of this part. So does that work as a formula? Not working as a formula. Okay, so that's working. 9.81 times, what was G1 again? It was 18,000 kilograms plus 2 times 1,800 kilograms plus 2 times 1,200 kilograms minus sine of this angle times, and I'm going to have 6 times 1,800 plus 12 times 12.25 times 1,200 and that whole thing is going to be over 4. So I'm going to come over here, go to the end there, divide by 4. Alright, so that's my total load there. And actually I'm going to put another thing here. Put in some units. So this is going to be in newtons. This newtons, newtons, newtons. Alright, so then here, our equation for that again was going to be equals 9.81 times G1 18,000 plus 1,800 plus 1,200 minus this. Okay, and then we're going to just find the single reactions. So it's going to be equal this amount divided by 2 since there's 2 A outriggers, and then equals this divided by 2 since there's 2 B outriggers, and that should be our formulas. So let's see what we've got. Paste those down. So that does not look correct. Sine of B4 Alright, let me double check. Maybe mine is doing degrees. Let me just change this to B2. That shouldn't change any result. Not copying that paste down. That is not making any sense either. Alright, I must have an error in my formula. I will put this on pause for a moment and see if I can solve that problem and I'll pick up back with the Excel sheet shortly.